Hello friends, welcome in Cadence tutorial series. In previous video I have explained ID versus VGS plot of NMOS. In this video I am going to explain about ID versus VGS plot of NMOS. So in previous video I have made this schematic, so if you have any confusion, so go in previous video and see that. Now in this video I am going to plot ID versus VGS plot. So here VGS is basically 1.8 volt and VDS, that is drain voltage, is also 1.8 volt. So for this schematic I am going to see this characteristics. So again go to launch, then ADE L, then here edit, go to DC analysis, then in component parameter select the component you want on x-axis. So actually I want to plot ID versus VGS, so VGS will be on x-axis. So select component VGS, so click on select component, then go to your schematic and choose this VGS, then click on DC voltage, then OK. After that go to this windows again, and here you can see this component name, that is V output, and the parameter is basically DC. Now you have to give the start and stop voltage, so I am giving it 0 to 1.8 volt because I want to see this plot from VGS equals to 0 to VGS equals to 1.8 volt. Then everything is okay, click on OK, then again go to ADE L and run this simulation. But before running this you have to select the output node. So here go to edit, right click and edit, then from design you should select that node, that is drain, because I want to see the ID versus VGS plot. So click on this node, this drain of NMOS, for seeing the current ID, because it gives the current entering into this NMOS from this node. So for current you have to select node, I already explained in previous video, and for voltage you have to select the wire or net. So I am selecting this node for seeing the current. Then again go to setting output, you can see here it have come, then click on OK, then go to ADL terminal, and everything is okay. Sometimes there are multiples technology library file is automatically selected, so you have to uncheck them. So I'm going to uncheck 1945 technology file. I am only selecting this 180 nanometer because I have already selected 180 nanometer technology library. So click on OK, then run the simulations. So you can see this is the ID versus VGS plot of NMOS. Now I want to see its parametric analysis, because I want to plot this ID versus VGS for various VDS. So if we vary the value drain VDS value, that is drain to source voltage, so there will be different plot for that. So how it is actually varying, we are going to show it using parametric analysis. So again go to schematic, then you have to make this DC voltage as variable. So click on this, then press Q, then change this DC voltage to VDS because I want to vary this drain voltage. Then again press on check and save. After saving this, again go to ADL window. Then here actually I have made the drain voltage variable, so I have to copy it or bring it here. So in design variables, here you will see all variables you have made on schematic. So actually I have only declared one variable, so here click right click, then copy from cell view, so VDS automatically come here. Now you have to give this VDS value as 1.8 volt initially, then go to tools and go to parametric analysis. In parametric analysis, here you have to add variables, so I am going to add variable, and my variable is now VDS because I am varying drain to source voltage. So this is VDS, and I want to vary this VDS from 0 to 1.8 volt. So this will vary from 0 to 1.8 volt, and in this time I want to show some actually first I have to set this setup mode also. So I am going to see this setup mode as linear steps, and I have to declare that linear steps. So I want to see this ID versus VGS plot for different VDS, and the VDS range is basically varying from 0.3 volt. So this 0.3 volt is basically a step size. Then run on this. So after that you can see here it is simulating, and two plot is basically remaining, now one remaining only, and this is the last run. So after that you will get the plot of this ID versus VGS for different VDS value. So you can see now. So this plot is basically for 0 volt. So here now VGS is basically 0, VDS is basically 0 volt, here VDS is 0.3 volt, here VDS is 0.6, here 0.9. so step size is basically 0.3. so why it is varying this, then this is 1.8. so this is the various plot of ID versus VGS. Now you can change the color and make it wider from here also. Okay, so I am not going to change every time. So this is ID versus VGS plot of NMOS. Thank you.